We are going to discuss 17.2. The objectives for today's lesson, we will construct equations that show the heat changes for chemical and physical processes. We will also calculate heat changes in chemical and physical processes. The key terms, okay, you need to know the law of conservation of energy. Law of conservation of energy. Energy is neither created nor destroyed. Energy, the total energy of the universe, is constant. Energy can be changed from one form to another, but energy is not lost or gained. Can be changed. Temperature. Temperature is average kinetic energy. Average. Thermal energy, heat. Okay, so make sure those two things are not the same thing. Temperature is not Q, is not heat. For example, if you have a bathtub of water at a certain temperature, if I take a small cup, a cup of that big bathtub of water, and measure the temperature in the bathtub, it will be the same thing as the temperature in that small amount of water. The temperature is the average kinetic energy, but the heat in the bathtub will be more than the heat in the cup of water. Temperature, average kinetic energy. Calorimeter is an insulated device used to measure the absorption or release of heat in chemical or physical processes. Last time we did use a calorimeter. We have two different kinds of calorimeters. We have what we call a coffee cup calorimeter. It is a styrofoam. When we use a styrofoam, coffee cup calorimeter. A bomb calorimeter. That's where we have a calorimeter at constant volume. Okay, constant volume. Heat of combustion is the heat of reaction for the complete burning of 1 mole of a substance. Heat of combustion will always be negative. It is exothermic. Like we said last time, negative does not mean a negative energy. Energy is not negative. We talk about only the direction of that energy. Another term we will be using is enthalpy. Usually you will see change in enthalpy. You will see delta H. Enthalpy of a system is the heat content of the system at constant pressure. In other words, Q and enthalpy, they are the same thing, except for enthalpy is at constant pressure. If you have a container that is open, it will be at constant pressure. Enthalpy is the heat of the system. The SI unit, we said last time, the SI unit for energy is joule, capital J. But sometimes you will see an old unit, it is the calorie. So sometimes you will have to convert from joule to calorie. 1 calorie equals 4.184 joule. But in some of the papers, we will just be using 4.18. 1 calorie equals 4.18 joules. Remember last time I said when your C is capital, it really means kilocalorie. 1 kilocalorie equals 1,000 calories. Thermochemical equations. A chemical equation that includes the enthalpy change. If they include the heat as part of this equation, we call it a thermal equation. Last time we said exothermic reaction means when heat is released. For example, this is calcium oxide plus water. When you put them together, you form bonds. This is calcium hydroxide. Forming bond is exothermic. Okay? Forming bond. You are forming bond. Forming bond is exothermic. Okay? Release heat when you are forming bond. As you can see here, we are using delta H. It is change in enthalpy. Change in enthalpy. Breaking bond. This is sodium bicarbonate. You are breaking the bonds to form sodium carbonate. water and carbon dioxide. When you break bond, the reaction is endothermic. Okay, breaking bond is endothermic. You add heat to break bonds. So pull out your calculator. You can pause the video, take the time, go get your calculator. Let's solve it together. It says use the following equation. You have sodium hydroxide solid plus water yield sodium ion hydroxide ion plus. Now this is a thermochemical equation because the heat is part of the equation. Because the heat is part of the product, that reaction is exothermic. The heat is produced, therefore it is exothermic. So you can either write the equation like that, or you could put delta H equal that number, you put it as a negative number. So you either put it as part of the equation, or you write down delta H at the end. You need to put if it's positive or negative. Determine the heat release. Okay, so it is exothermic. When 72 moles sodium hydroxide is dissolved in water. You say hint, pay attention to the fact that the answer is positive for endo, and the reaction is the heat is negative for exo. So we already established that this equation is exothermic, therefore the heat will be negative. So how we solve it? We write down our given, which is 77.2 moles. This is NaOH. So you just use your conversion factor. They ask for heat. So I need my kilojoule here. This is my heat, and I will use moles here. From the balance equation, every time 1 mole of sodium hydroxide react, 1 mole sodium hydroxide, 445.1 kilojoule of heat will be released. So I just use my conversion factor, cancel out moles, and the answer is negative 34,400 kilojoule. Thank you. So it's just a matter of you do mole to mole ratio to find that heat. Now if we do significant figure, we have 4 sig fig here, and we have 3 sig fig here. If we express our answers with 3 significant figure, it would be that's what it is. Okay, thank you very much. All right, let's move on. This is straight from your textbook. Copy this straight. So listen carefully. When 25 ml of water containing 0.025 moles of HCl at 25 degrees Celsius is added to 25 ml of water containing 0.025 moles of sodium hydroxide at 25 degrees Celsius in a foam cup calorimeter. The reaction occurs. They ask you to calculate the enthalpy change. Enthalpy change in kilojoule. During this reaction, if the highest temperature observed is 32 degrees Celsius, assume that the density of water, the density of the solution is 1.00 grams per ml. They ask for enthalpy change. Enthalpy change, delta H. So I'm going to solve for Q. Okay? Q equal, remember our formula? MCAT. Mass time, specific heat time, change in temperature. MCAT. Therefore, Q, that's the heat, equal the mass. What is the mass? We have the total volume. We are adding 2 different things. It is 50 ml. This is the volume. But they gave me the density, which is 1 grams per milliliter. So the mass is What is the mass? It is 50 grams. Okay, the mass is 50 grams. Times. And then if we assume this is water, the solution is water, then the specific heat of water is 4.18 times the change in temperature. It is 32 minus 25. 32 minus 25 degrees Celsius. So Q equal 1,460. 1,460. What is the unit? It is joule, because the specific heat is joules per gram degree Celsius. So this is joule. But now let's see what happened. Listen carefully. The temperature of the solution went from 25 to 32. That means the water absorbed heat. Is that right? But when they ask you for enthalpy change, they are asking for the heat of the reaction going on in that solution. So if the temperature went up, that means that reactions going on in that solution is releasing heat. So delta H equal, is that negative or positive? It is negative. Delta H is negative, and they ask me for delta H in kilojoule. So what is this in kilojoule? It is 1.46 kilojoule. So this is your delta H, 1.46 kilojoules. So I need for you to really think, if the reaction is releasing heat, the temperature of the solution went up, but the heat of the reaction is exothermic. It's releasing heat. So you have to pay very, very close attention. Let me see if that's what we have. Negative 1.5. Why? That's because we need to express it in two significant figures. Is that right? It is a negative 1.5 kilojoule. This is your delta H. It is enthalpy. Okay, just multiple choice. Tell me what you think is the answer. The change in temperature recorded by a thermometer and a calorimeter is a measurement of what? Think of the the virtual lab. Okay, if water has a very high specific heat, therefore the change in temperature will be low. Okay, if the concrete or the sand has a low specific heat, that means the change in temperature will be high. So they ask here, the change in temperature is directly related to what? Okay, high change in temperature goes with low specific heat. So it has to be specific heat. Okay, next. For the reaction, here's the reaction. We already saw that. This means that 65.2 kilojoule of heat is that absorbed or released? It is released. How do we know? Because the delta H is negative. Next. How much heat? Calculators. Let's get our calculators. How much heat is absorbed? Heat absorbed by 325 grams of water if its temperature changes from 17 to 43. The specific heat of water is 4.18. So get your calculator. This is our Q. This is our MCAT. The mass is 325 grams times the specific heat of water is 4.18 times the change in temperature is 43.5 minus 17. So what is the answer? I heard C. Let me see. Which of the following is a thermochemical equation for an endothermic reaction? Which one is endo? I heard D. You are right because the heat is on the reactant side. Is that really D? No, it is not D. What is the answer? The right way to write it is B. Am I right? Because D, look at this. You need a plus. You need to add the heat. Okay? All right. How about this one? Oxygen is necessary for releasing heat from glucose in organism. How many kilojoule of heat are produced when 2.24 moles, calculators, 2.24 moles of glucose react with an excess oxygen? From that balance equation, this is the heat release for every 1 mole of glucose. So they just ask you for 2.24 moles. The answer is, calculators, let's go guys, let's go. What is it? D. It's just this number times 2.24. Is that right? All right. It's mole to mole ratio. And I'll see you tomorrow. Thank you for your patience.